Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hussein. My text number is TE230118. I'm from group 4. So today I'm going to present about question 1A and B. For the question 1, we got a limit for the double integration, which is for the x is equals to 2 and equals to 1. And for the y, we got the limit which is -1 and 1. So the equation is 2xy squared minus 4x cubed towards dx and dy. For the dy, we got the answer is 4x over 3 minus 8x cubed, and then we use the towards dx, and we produce and we put the limit, and the final answer is -28. So from this answer, we can compare with the simulation, which is using the MATLAB, and we can see the answer is also -28. So means the manual calculation and also the software calculation is similar, and the answer is correct. Alright, so we continue for the question 1B, which is also the double integration. What we need to find the region bounded, which is a shaded region. So we have the limit, which is for the x is equal to 1 over 3, x equals to 0, and the limit for y equals to x cubed, and y equals to x cubed and y equals to 0. So the equation is x plus y towards dx and dy. So we got the graph, which is a parabola graph, and also the linear line. Y equals to x cubed is parabola graph, and x equals to 1 over 3 is the linear line. And we can see which is here it's a rigid bounded. So we want to find the area. So we put the dy first, and then we got the answer for dy is x cubed plus x to the power 4 over 2 dx. And then for the limit x equals to 1 over 3 and x equals to 0, x cubed plus x to the power 4 over 2 dx, we use the integration, and the final answer is 17 over 4860, or 0.0035. So this answer can be proved by our simulation at the MATLAB. So we put the common, we put the coding, and then we put the coding for the value for double integral, which is we got the answer 0.0035 at the software. So means the answer is correct. And also we can find the rigid bounded, which is at the MATLAB. So the area is same like our sketching in the manual calculation. Means our manual calculation and our simulation have the same answer, which is 0.0035, and also the shaded region.
Alright, Assalamualaikum. My name is Sami Aziz bin Marahim with metric number DE230130. So today I'm going to present for the question 2. First of all, I will start with integration with respect to z, and then I will use u substitution and integrate with respect to u, and the final answer will be 1/3 cubic unit. As you can see here, this is the graph for the YZ plane, and for the projection of YZ plane, and then this is the graph for the cylinder. Alright, now we move on to the next part, which is simulation. When I run this command, I get the answer, which is 0.3333, which is same as in the calculation 1/3 cubic unit. Right, after I run the command for the graph shown here looks the same just like the calculation part.
Hi, my name is Tan Shunze with matrix number DE230127. So I'm going to present the calculus project for the question 3. So now as you can see, this is the manual calculation for the question 3, and this will be the question. And from this question we can get this graph, and upper half here we can get the r is more than 1 and less than 2. This is for the first, and the next is 0 is more than 0 but less than pi. So we can get the equation from here, and then we sub in the r together, and we get r over 4. So this is the equation. Next, we integrate the first, which is 1 to 2. Integrate, we sub in, and we can get the answer is 31 over 5. And next, we let the u equals to cos delta. So we will get sub here, sub there, we will get the answer is du over negative sine delta equals to d delta, and we sub in here. So the cos square delta will become u square, square root u square bracket 1 over negative sine delta bracket. So the delta will become du. And next, we cancel sine delta and negative sine delta. We will get the equation is u square du. And we integrate again. Integrate. And last, we will get the answer is 62 over 15 unit square. So now we will move to the simulation. This is the coding that I done for question 3. So after run, we'll give the result is 4.133, which same as the manual calculation, 62 over 15. And this is the graph for the simulation. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Haris Akmal bin Perulani, metric number DE230133. Now I will present about the question number 4 to find the surface area of portion of paraboloid. Use the double integral z equal to x squared plus y squared below the plane z equal to 1. So first step, we use the surface area formula. Integration of region square root of dz over dx squared plus dz over dy squared plus 1. Then differentiate dz over dx and dz over dy. We substitute into the equation, then we will get the 4x squared plus 4y squared plus 1. We factorize value of 4x squared plus 4y squared equal to 4r squared. Then the new equation equal to 4r squared plus 1. We substitute the new equation into the integration of r dr d theta. Then we substitute the value of u equal to 4r squared plus 1. Then we will get the equation 1 equal to x du equal to r dr. We change the integration of r dr to u du with limit for r 0 to 1, limit for u 1 to 5. So we change the integration, we will get the answer 1 over 12 multiply 5 power of 3 over 2 minus 1. Then we integrate for d theta, we will get the answer equal to 2 pi. Final answer, we multiply integration of d theta and du, we will get the answer equal to 5 power of 3 over 2 minus 1 pi over 6. For comparison, manual calculation, we use the simulation in MATLAB. So we get the same answer, 5.330414. For graph, we will get the graph like this.
My name is James Pao and my metric number is D2300F4, and I'm going to present the simulations of question 5 in our group project. So I have done my question 5 manual calculations, and this is the questions. The question 5 is the triple integral, which is to 3, 0 to z, 0 to y, exponent x dx dy dz. The triple integral of ds dy dz. And finally, I get the answer of negative 7 over 3 minus exponent power of 2 plus exponent power of 3. And now I will going to do the simulations on MATLAB, and let us type in the coding in MATLAB. So we have already complete to type in the coding. So based on this coding, at first we have to type in our questions, which is the triple integral, and define the functions to integrate. And come to the step 1, the innermost integral over x, and step 2, second integral over y, which is from 0 to z. Step 3, outermost integral over z, for which from 2 to 3. And after we run this coding, and we can get the value of the triple integral is 9.1965. So based on our manual calculations, we can get the answer, which is negative 7 over 2 minus exponent power of 2 plus exponent power of 3. So if we type in the type in the answer inside the our calculator, and we can get the same answer, which is 9.1965, which has already displayed on the MATLAB. This one. So this simulations is correct, and it can run. So that's all for me. Thank you.
Alright, now move to the question 6, which is the triple integration. So first we find the z equals to 1 minus y. So this is the graph. And then the second one is the y equals to x cubed, and we got like this. And also when z equals to 0 means y 0 equals to 1 minus y, and y equals to 1. So we got a limit for y. And then we can put it inside the one equation, which is for the x, y, and z range towards dz, dy, and dx. So x equals to y, x equals to 1, x equals to -1, and y equals to 1, and y equals to x squared. And also for the z equals to 1 minus y, and z equals to 0 towards dz, dy, and dx. And then we make the first integration towards dz, and we got the answer is 1 minus y. And then towards dy, we got the answer which is 1 minus 1 over 2 minus in the bracket of x, x to the power of 2 minus 1 over 2 x to the power of 4 towards dx. And then the last integration is towards x, and we will get the answer which is 8 over 15. So to prove this answer, we make it inside the MATLAB software. So we put the command and also the coding, and we get the same answer, which is 0.53333. If we convert, we will get 8 over 15. So means the answer for the simulation and equation are same. And also we get the 3D graph, and this is the 3D graph solid bounded by y plus z equals 1, y equals to x cubed, and z equals to 0.